Welcome to our next presentation in our Waves and Light unit. This is presentation number 4 of our transverse waves and light. Let's just jump right in. Our learning goals for this video to be able to compare the different behaviors of light waves, and the two behaviors we're going to look at today are reflection and refraction. You'll be able to show examples and explain what reflection and refraction are. Your slotted notes begin at this point. So page 7, if you want to get that out, take notes. All right, so we've been talking about light in this series of lessons, and light travels in waves, okay? It's energy, and light can behave in different ways. When light is shown, it can be reflected, or it can have reflection, it can have refraction, it can have diffraction, it can have interference, or it can have absorption. Okay, now maybe you haven't heard some of these words before. Maybe you've heard all of them before. We're going to dive into each one, but today we're going to look at reflection and refraction. Okay, because of the main ones that we deal with every day, and I think that'll be enough for one sitting. So let's just move forward. So reflection is another word for bouncing. All right, so reflection of light happens when a light wave strikes an object and bounces off of it. Okay, like an image in a mirror. If you've seen yourself in a mirror, okay, then you've seen your reflection. You have seen light hitting an object, bouncing off that object, and going back to your eye. Specular or irregular reflection is when reflection that occurs on a smooth surface and when light beams are reflected at the same angle. Okay, so that's like you stand in front of a mirror. Okay, you see yourself just as tall as you are, and just as far away as you are. Now we know some of that can change if we change the way the light is reflected, or how the shape of the mirror, which we'll talk about that in just a moment. Or it can diffuse reflection. Okay, diffuse. This is when the reflection that occurs on a rough surface when light beams reflect at many different angles. Okay, so if you take something like a smooth mirror, you can see yourself perfectly fine. But if you look at something like a coin, okay, that has different level surfaces, and if you look at yourself in it, it may look different because the reflection has been diffused. All right, moving forward. So when if we think of this line here as the mirror, all right, and we're standing here, this is the normal line, the straight 90-degree line of the surface. Now, the incident beam is the beam of light that we are using to see. The reflected beam is what is being reflected off of that surface. I'm sure we're all familiar with taking a mirror and shining a flashlight in it. Okay, so if we shine a flashlight in this angle, then we get an identical angle reflected off of it. Okay, if you ever want a wristwatch, you ever had a watch on, you're sitting there, the sun shines on your watch, and you move that beam of light around, and sometimes you shine it in somebody's eye and just mess with them, that's the reflection of light. So I think we understand that. And the reflected beam is the exact as the beam of incident or incident beam. Here's some specular reflection, which is just the smooth surface. Okay, we can see that. It's like a mirror. It bounces off smooth, comes back up smooth. Now, diffuse reflection, like we talked about, has rough surfaces. So this just may be, when I say rough, it doesn't have to feel rough. It could just be different levels. So it may be something like a puddle of water or a coin or something that has different angles that light's bouncing off of, so you won't see a clear reflection. You get beams of light bouncing every which way. The law of reflection, all right, it's just like we said before. The law of reflection, all right, means is the angle of incidence equals the angle of reflection. So the angle of incidence, the flashlight on the mirror, that is the most common one. I think we can all understand that because we've all done it before. So we take that flashlight and we shine it into the mirror, and whatever angle that we shine it into the mirror with, we're going to get that angle coming out of the other side. Okay, so the angle of incidence is the incident. Think about, when the incident happens, that's where we get our source from, is where the incident. So that's the source of light is shining into the surface, and then we get the exact reflection off the other side. That's called the law of reflection. Okay, they're always going to be equal angles if it's a smooth surface. So here are just some more examples of reflection. This first picture up here, okay, we see the specular, where you get a smooth transition when it bounces off very smoothly. And then we got this diffuse reflection where light beams come in, but they're all bouncing off in every which direction because of the uneven surfaces. The second picture, we see the, I don't know what this is called, but I would call it mirror lake, because look at this, you get the exact reflection of the mountain and the trees and the sky, which we see these down here on the other one. Here's smooth water surface is a specular. See how it just looks like it's an exact copy of the mountain. And here we have wavy waters, which is like a diffuse reflection. So you can see the shape, but it's not exactly perfect. It's not the exact replica of the mountain in the sky. Side question, why do they have this written backwards? Does anybody know that? Why do you think they have that written backwards? If you think to yourself, they have it written backwards because if you look at something in a mirror, if you see something written down and you look at it in the mirror, it's going to show you the reflection. It's going to write the word backwards. So if you put the word backwards on the front of a vehicle and you look in the rear view mirror of a car, it's going to spell it correctly. So if you're driving down the road and you see this coming up, you're going to see ambulance written on the front of that car, which would most likely have us pull over or get out of its way to allow it to perform its duty. That's just a little bit of extra information. Another reflection surface that we use a lot of, it's mirrors. Okay. Now there are three types of mirrors. Okay. There's a plane mirror. So the plane mirror has a flat surface. This is probably what you have hanging in your bathroom or on the back of a door, or what you use to get ready in the morning time, or put your makeup on for you ladies. And this is what you use in the house. Usually a plane mirror. Okay, people use this to reflect, to see themselves, or men use it to shave, or to see, like soldiers might hold up a plane mirror to see behind them, right? So that's a plane mirror. It's flat. That's what we're used to. Now the next one is concave. Okay, so the next two words I'm going to introduce to you, the first one's concave, and the other one's convex. Concave and convex. All right. So first we're going to talk about is concave. Now, if you've never heard this word before, and I say concave, all right, imagine in your mind, if you will, a cave. All right, a cave goes into a mountain, right? It's an opening. It's an opening that goes in. So you can walk into a cave because it has an inward shape. Think about a spoon. All right, you see that spoon right here? This spoon has a concave shape because it is inward, okay, like a spoon. So remember that, all right? Because look at this battery sitting in front of it. A concave mirror is a mirror that is curved inward like the inside of a spoon, all right? So think about a concave like a spoon. What it does is it inverts the image. Now, inverts means it produces it upside down. All right. So if it inverts this image, see how the Duracell has a copper top and a black bottom? If it's inverted, it'll have a black top and a copper bottom. Okay, so concave turns that image upside down. All right, so the next one is a convex mirror. All right, now we see these all the time. If you ride a bus, okay, look at this mirror here. Okay, the convex mirror. Excuse me. Convex mirror is like the one on the. Is a mirror that curves outward, like the back of a spoon. Okay, so the spoon on the back side of the spoon, it goes outward, just like this bus. I know that for everybody who's ridden a bus or has been around a bus has seen these what I've known as blind spot mirrors, but they're convex mirrors. And what they do is they show the image right side up, but it makes everything smaller, right? So you're able to see a wider view. That's why they put that on there, so you can see all around the bus or the car or whatever that you have it on. You also see these convex mirrors in like gas stations or stores or somewhere like up in the corner. That big mirror that's like a back of a spoon is real round, and you can see the entire store. And that whole thing's a camera, right? So it sees what's going on all the time, and it shows you exactly a good right side up image. Okay, so that's the difference between concave and convex. Think of a spoon. Concave is like the front of a spoon that caves in. Convex is like the back of the spoon that curves outward. All right, that's the way I remember it anyway. So here is a simple diagram of a concave mirror and a convex mirror. All right, now if you will, take a look here, and you see a concave mirror. Concave, see how it goes inward here, like the front of a spoon. All right, so if you have an object here, okay, and here's your focal point. Now this is the point of reflection right here. Okay, all right. So if you have it farther back, okay, then it's going to be produced. I'm sorry. Here's your real image right here. Here's your image. So here's your object. You got the point up and the eraser down, and it's looking toward the mirror. You got your focal point. Okay, this is where they intersect. The lines intersect, and then the concave mirror produces it upside down. As you can see, this object is the point here and the eraser here, and then the reflected image, the real image, has the eraser at the top, point at the bottom. Okay, you see it does a complete 180, turns upside down. That's a concave mirror. Okay, now if you move it closer, your focal point moves back, but the front of the mirror, okay, and the back of the mirror is exactly the same. Okay, so an object less than one focal length away from a concave mirror forms a right side up virtual image. The dotted lines trace the reflected rays behind the mirror to find the virtual image right here. So the concave, okay, just remember that it comes in like a spoon. Okay, now if we flip that around, if we turn that around and we have a convex mirror, the convex mirror is like the back side of the spoon. You see it? It's like the back side of the curve. Okay, so the light bounces off of that differently. Okay, it almost makes a bouncy from the object to the mirror and back. Okay, now if you look through it, the reflection is going to be a lot smaller. Okay, but you're going to see the exact thing that you see, and it's going to be right side up. Okay, so just remember the difference between concave and convex, and that'll and you'll be fine when we talk about mirrors. Okay, the second thing that we're going to talk about is refraction. All right, now refraction is the bending of light as it passes at an angle from one medium to another. Now, remember we said medium was a form of matter. Okay, so when light passes through matter, usually it's air or water for refracting. then it bends. The light bends in a way that makes an image look different. Okay, so example, I think, I don't know, maybe everyone has seen this, but if you put a straw or a pencil or something in water and you look at it from the top, it looks like the straw's broken, or it doesn't look right. Well, what's happening is you pull it out, the straw's straight, right? So what's happening is when you enter that straw in water and then light passes through that water, if you look over here, so when light goes through air, it travels at a different rate, okay? It's a normal speed of light. When it hits water, it slows down just a little bit, right? So it's caused by changing speed. So when it slows down, it changes angles, angle of incidence, right? So when light passes through a more dense object like water, it slows down, light bends. Then we see an object a different way. All right, it always bends toward, okay, toward when it goes slower. So if it's going from air, like this one here, if it goes from air to water, it slows down, right? Now, if we reverse that and light is going from water to air, it speeds up, right? So when it goes to a less dense object, it's faster and it goes away. It speeds away. And the object still looks bent, though. I don't know if you've ever been in water and looked out of the water. Things look kind of fuzzy anyway. Okay, so refraction is the bending of light waves. Now, refraction depends on a couple things. It depends on the speed of light in the medium, okay? So a medium of air, the light travels faster than it does in a medium of water. So it depends on the speed of light in the medium and the wavelength of the light, right? Remember before in the last video, we talked about invisible light. Different colors have different wavelengths. So the shorter the wavelengths, like violet, okay, they're going to bend more because of the high energy. All right, there's a little picture down here to help us see that. Okay, so refraction depends on two things: the speed of light in the medium, so if it's passed through air or water, or if it's what wavelength the light has. Okay. Here's another visual representation of what we were talking about earlier. Now, to the cat, let's look on this side first. Now, they're the same thing, but we're going to look at it here. So if the cat's sitting on the dock, he's looking at the fish, right? So the light hits the air and is moving real fast, and it hits the water and it bends down, slows down. So there's the fish right there. But to the cat, if you look straight, it's going to look like it's right there, right? So where the cat sees the fish is not really where the fish is what I'm saying. And vice versa for the fish. Once the light bounces, it reflects off the water, comes out of the water for the fish to see the cat will look where it's a lot higher than what it really is. It'll look, because the light bends and it causes the object to look a lot different than where it actually is in space. Now, you can try this at home. This is the broken pencil experiment, or straw, or pen, or anything. So, number one, look, here it is. Get a small glass of water like this and fill about halfway up with water. Make sure the glass is clear so you can see through it. Place the pencil in the water and look at it from straight ahead, and the pencil in the place in the exact center. You'll see that the pencil's a lot larger than the pencil that went in. Okay, and if you look up at it and you place it to the left of the center, you'll see that the pencil looks broken. It looks like the top part is away from the bottom. And it'll be the same thing if you look at it from the other side. All right, now that is just the refraction of light through the water, because it slows down. So through air, it goes really, really fast, hits the water, slows down, and it bends. So when when the light bends, it makes the object look like it's closer or farther away than what it actually is. Over here to the right is a explanation for this. So the image of the pencil is located where the refraction rays intersect. So down here are your eyes, and you're looking at this thing with a straight angle. Well, when that light bends, it takes the object and it moves it to where your eyes, your brain thinks it should be, right? So you think it's straight ahead, but in reality, it's right here, okay? And it's all that has to do with the speed at which the light travels through the medium. Because when it hits air, it goes a certain speed, then it slows down and it bends. When it bends, that's what we call refraction. Yeah. So now, lenses. Okay, lenses. Where do we know where lenses, or where do we see lenses most of the time? Well, if you wear glasses, you have lenses, and they are just like a mirror. Okay, just like reflection, there's different types of lenses. So the first lens that we know of is a transparent object, okay, that refracts or bends light waves such that they converge or come together, or they diverge, they go away to create an image. Okay, now, so a lens will either make light waves come together, or they'll make them go away, right? Now here we are back to concave and convex again. So still think about that image of a spoon, right? The concave is the front, the dip side of the spoon that goes in, and the convex is the outside of the spoon that goes around. So if we have a concave lens, right, concave, then the lens is thinner in the middle. This is an example over here of a concave. They're thinner in the middle and wider at the edges, and the image gets smaller. Okay, this is what eyeglasses are for. So that's really what your eyeglasses are doing. Okay, so why do people have bad eyesight? Why can some people not see very, very far? Some people can't see close. What it is your eyes can't refract the light, can't bend the light in the correct way. Something's wrong with your eyes. So what they call them corrective lenses. So what they do is the glasses take the light that is bouncing off an object, and it bends it in the correct way that your eyes see it, and makes a clear image. I don't know if you've ever been to the eye doctor and he tries different lenses and he says, "Is this better or worse? Better or worse?" They're just trying different concave lenses to see how thick do you need it, because the thicker that concave lens, the slower it moves the light through it. So you look through this light. See this light moving through this concave lens? As it moves, it's bending up, bending down. So the thinner or thicker you get it, the more it bends the light. So that's a concave. Convex is the opposite, okay? The lens is thicker in the middle than at the edges. The image gets larger. So this is for magnifying glasses or camera lenses. Our human eye has a convex lens. Eyeglasses for people who need to see up close, microscopes, binoculars, telescopes. Convex lenses are all around our world all the time. Anything we want to make something bigger, okay? Magnifying glasses are probably the most ones that we've used, or cameras. The camera on your phone has a convex lens, and when you zoom in, that lens opens up a little bit more and lets that concave lens see more of the object. Okay, so I hope you understand that. So summary of today's video. Okay, we really only touched on a couple different behaviors of light, but the light waves can reflect, refract, diffuse, interfere, or absorb. Today we only talked about reflection and refraction. So reflection is when light strikes an object and bounces off of it, right? So we see that as the law of reflection means that the angle that it comes down and goes into the object is the angle that it bounces off the object if it's a smooth object. If it's a rough object, then it bounces off in a bunch of different ways, and we don't see a clear image. Okay, so reflection is just bouncing off of an object.
No, it's not. That's the second. Well, that's
Refraction,
I know that's the same
or known as the bending of light waves, is when light passes through a medium and it slows it down or speeds it up. Okay, so if it's going through air and it hits water, then the light slows down. And as something slows down, like a car or a truck, it starts to change direction, right? Like when we talk about acceleration. When we slow down, we're changing the direction in which we're going. So, so refracting light is just the bending of light waves. Right now, that can be in the shape of a convex or concave lens or mirror. Now, the key point that we talked about convex and concave was that if we think about a spoon, right? So the concave part of the spoon would be the inside where the spoon we use to eat with, it dips in. The convex mirror would be the outside of the spoon that goes outward, right? So that's in the form of a mirror. If we think about lens, the concave mirror is wide at the top, narrow in the middle, right? Because it concaves in. And a convex mirror is the exact opposite. It's narrow at the top and wide in the middle. Okay, and the concave mirror is for nearsighted people that need to see far, and the convex mirror is, the convex lens. Excuse me, the convex lens is for like magnifying glasses, people that need to see, make things larger. Okay, so that's a jump into reflection and refraction of light. I hope you've enjoyed this video. Please go back and look through it if you have any questions or if you missed any notes. Let me know if you have any questions. Have a great day.